So in Poly 4, I'm going to have to teach you some theorems. Some of them you probably learned already. I'm sure you did learn it. You guys just probably forgot. Do you guys remember the fundamental theorem of algebra? Good. That's probably one of the most important theorems you learned last year. A fundamental theorem of algebra. And if we record, and since you guys are like period 1, probably lots of times you're going to record in the first class, then we only use this side of the board, because then that's all that they can capture right there. So the fundamental theorem of algebra says if you have a polynomial equation of degree n, then you will have n solutions. Does that sound familiar? For example, the equation that we're going to do today, see, I prepared it over here. 2x to the 4th minus 11x cubed plus 24x squared minus 13x minus 14 equals 0. How many roots will this equation have? 4, because it's degree 4 is the highest power. The fundamental theorem of algebra says that you will have exactly 4 roots. Now do you remember it? You mean your teacher never told you if the degree is 5, then there's going to be 5 answers? Okay, it doesn't matter because I'm teaching you like you don't know anything, right? Okay, now how do we find these 4 roots? What do you do? What do you do? Oh man, it's a hard time breathing, man. Woo! Okay, so the first thing we're going to look at is the rational roots theorem. Does it seem kind of warm too? Yeah. Let's turn it down there. Okay, so the rational roots theorem says that if there is a rational root to an equation, it will be of the form p over q. Because what is a rational number? A number that can be written as a ratio of 2 integers, right? Okay, does that sound familiar? P over q? Okay, so the rational roots theorem says p will be a factor of this, q will be a factor of that. Does that sound familiar? Doesn't matter because I'm teaching you like you don't know anything, right? So on the next quiz, well not the next quiz, but the quiz after that, I'm going to ask you, what are the possible rational roots? And you have to list them up. So how do you do it? Well, you look at this last number. What are the factors of 14? Come on, this is pre-algebra, right? This is like 3rd grade, right? What are the factors of 14? Plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14, right? I'm not going to write the plus or minus just yet. And then you look at this number. What are the factors of 2? Plus or minus 1, plus or minus 2. So if you take all the combinations of these numbers over these numbers, those are called the possible rational roots. You remember doing this last year, right? It doesn't matter because I'm teaching you like you don't know anything. Okay, so 1 over 1, so plus or minus 1. 2 over 1, plus or minus 2. 7 over 1, plus or minus 7. 14 over 1, plus or minus 14. 1 over 2, so plus or minus 1/2. 2 over 2 is 1, which you already have on the list. 7 over 2, plus or minus 7 over 2. And then 14 over 2 is 7, we have them on the list. These are called your possible rational roots. In other words, if this equation is going to have any rational root, it has to come from this list. So in other words, no sense trying 3, 4, or 5 because they don't have a prayer of working. Only these numbers have a chance of working. Okay, because When you're finding the roots of a polynomial equation, it's basically a guess and check process now. So what you have to do is you have to reduce the amount of time that you're going to spend, because you're not going to have, I'm going to give you, probably on the quiz, you might get a fifth power one. And with no hints. How do you find out 5? Well, you gotta do synthetic division, but it's a guess and check process. So let's do that now. Now, before we go any further, did you guys learn the upper bound, lower bound theorems? How come some of you saying yes and, well, what is he talking about? Okay, if you do synthetic division by a positive number, and all the coefficients come out non-negative, then we call that number in the box an upper bound for the roots. In other words, there will be no root bigger than that. So if you ever get to an upper bound, don't try any numbers above it, because they're not going to work already. And then, how do you tell what a lower bound is? If you do synthetic division, oh my God, how am I getting so winded? Maybe I'm talking loudly, that's why. If you do synthetic division by a negative number, oh my gosh, I'm getting lightheaded too. If I faint, somebody got to call the nurse, I suppose. Wait, let me catch my breath here. What is happening? It's much easier to do it on Zoom. Or it's much easier to do it without a face mask. Okay, so if you do synthetic division by a negative number, then you guys remember what to look for? If the coefficients alternate positive, negative, then that number is a lower bound. And that means don't go any below it, because there will be none below it. So we're going to use all of these tools to figure out the roots of this equation. So here we go. So this is what you gotta get good at, but it takes practice. Okay, so remember the key to solving polynomial equations, you make one side 0, and then you need to factor this side. That's the hard part. How do I factor? So we write down the coefficients, 2, negative 11, 24, negative 13, negative 14. Okay, what number should I try? You try numbers that are from this list. Now what I like to do is I start with 1, and then I work my way to the upper bound. And then when I start the negative numbers, I start with -1 and I go down to the lower bound. And then after, then I'll try the fractions, because fractions, I guess sometimes they're going to be roots, but I'll just save those for last. But everybody has a different technique. And like I told you on the videos, I had a student once, class of 1999, he never did synthetic division, he just did factor by grouping every single time. But there's not too many kids that can do that, but because you really got to practice. So what I would do is I would start with 1. Okay, go. You guys remember how to do synthetic division? Did I do that correctly? Of course, I'm the teacher. Okay? Now, 1 didn't work, because remember, we're looking for the remainder to come out 0. Remember the factor theorem? If the remainder is 0, then x minus this number will be a factor, but it didn't come out 0. Is it an upper bound? Well, are all of these numbers here non-negative? No, so this is not an upper bound, so that means you probably should try numbers bigger than that. So what would be the next number to try? See, now I gotta erase, because this is guess and check, man. Or you can just, I don't know, how can you do this? Well, I guess if you're doing it on notability, you can just, what do you call that thing? Go back, whatever. Okay, the next number I would try is 2. Okay, so let's do it. Check my work now, because I'm lightheaded here. Woo! We got it! The remainder came out 0. Now don't do what students do every year. They want it to come out 0, so you know what they do? They force it to come out to 0 when it's not really 0, so don't fake it. Okay, so what does that mean? That means x minus this number is a factor. So I can factor that as x minus 2. How do I get the other factor? You look at the depressed coefficients here. Ah, that's cute, fool. Wow, it's hard to do math when you're lightheaded. Woo! That's okay, if we get it on video and I pass out, then maybe the administration will give me something else I can wear. But we got it on video. Okay, well now, I got it down to a cubic. That still needs to be factored. So what you're gonna do is you're gonna do a brand new synthetic division problem now, just on this. But that's what you have here. So in your head, you gotta be thinking, factors of this over factors of this. So in your head, you're thinking, okay, what are the factors of 7? 1 and 7. Here, this is what, here, this is your head. Factors of 7 over factors of 2. So what are the factors of 7, 1 and 7? What are the factors of 2? 1 and 2. So if you take all the combinations, plus or minus 1, plus or minus 7, plus or minus 1/2, plus or minus 7/2. Okay, should I try 1 again? Should I start from the beginning and try 1? No, because if 1 is not a factor of this, then it's not going to be a factor of this, right? So it'll be waste time trying 1. Should I try 2 again?
No.
Why not? Is there such thing as double roots? Yeah, so you should try 2 again. There are such thing as double roots. We have not eliminated 2 yet. Oh. Okay, it didn't work, and it's not an upper bound because look, these numbers are not all non-negative. So what should I do then? What should I try next? What's the next number on the list? You gotta look at this list now. Don't look at this list, you gotta look at this list now. Should I try 7? Well, yeah, you can. Well, let's just do it for funsies. Whoa, what is 59 times 7? 350 plus 63. What did I just say? 350 plus 63, 413. Did I do that correctly? I'm lightheaded, you know, might not work so well in my brain. Anyway, no, the remainder did not come out 0, but look, it's an upper bound. But it doesn't matter because wasn't that the biggest number on the list anyway? So it really didn't matter. So now you have to decide, should I try the positive fractions or should I go the other direction in the negative numbers? It's up to you. You just got to be able to do it quickly. Okay, if I were me, I would go in the negative direction. Okay, let's do -1. Now, the remainder didn't come out 0, but we just learned something. What did we just learn? That's a lower bound. When you do synthetic division by a negative number and these alternate, then that's a lower bound. So that means don't try any number below it because you're just wasting your time. So now we kind of narrowed it down. Maybe -1/2 would work, +1/2, or +7/2. It's going to be one of those 3. Which one you want to go with? Okay, we're the -1/2. Oh yeah, we got it. That's what you want to see, remainder 0. So that means x minus this number, which is x plus 1/2, is a factor. And what's the other factor? You look at the depressed coefficients. Okay, now you don't have to do this, but this is what I do. This kind of looks ugly because of this. So what I do is I factor out a 2 from here. Can you see you can take out a 2? I take out a 2 and put it over there. There you go. Doesn't that look nicer? Now once you get it down to a quadratic here, you can either factor it or use the quadratic formula, right? Anyway, does that look factorable? How can you tell if a quadratic is factorable again? The discriminant is, we just did this in lin quad.
0.
A perfect square. Let's see if we can do this in here. What is b squared minus 4ac? 16 minus 28. Negative 12. Is that a perfect square? No, so this does not factor, so you gotta use quadratic formula. So what are your four roots then? X equals 2, negative half, and if you use the quadratic formula, negative 7 plus negative 3, so that's gonna be 2 plus or minus I root 3. I'll just do that in my head. Some of you are like, how are you doing that? I complete the square. You know, when this number is 1 and that number is even, it's really easy to complete the square in your head rather than use the quadratic formula. Watch, this is what I do in my head. I put the negative 7 there, add 4 to both sides to complete the square, like that. Square root both sides, no. And then add 2, and that's how you get 2 plus or minus I root 3. But whatever, do whatever you want. Just make sure you get that. So here are the four roots, and there's no double or triple roots, they're all single roots, yeah? And there you go. That's what you're gonna do in tonight's homework. So you're gonna be given polynomial equations. Sometimes it's gonna be a word problem and you got a polynomial equation, so you gotta be able to solve it. So again, how do you solve polynomial equations? You make one side 0, and then you gotta factor the side. How do you factor something when it's cubed or bigger? Synthetic division. But like I said, it's a guess and check process. So that's why we use all of these theorems, right? The rational roots theorems and the upper bound, lower bound theorems to reduce the work. Otherwise, we're just going to be guessing all day long. All right. Any questions? Why was that so hard work? Shoots, I've been riding bike and running a little. I haven't breathed this hard. What's going on? Okay, that's today's lesson. No question. Oh, we'll finish early. What, you guys expect to play games? Is that it? Maybe. Okay, let me turn off the video. And we actually only have one more lesson left in poly, you know. And that's, well, you'll find out tomorrow. Well, not tomorrow. Friday, I guess, yeah?